So section 10.3 in chapter 10, we're talking about vectors. Okay. Yes, we are still focusing on matrices, but today is just a little break from that, talking about vectors. Okay. Talking about vocab quick. You all know what direction is, right? What describes direction? Give me an example. An arrow, right? Or even north, east, south, west, up, down, left, right. We all know what direction is, yeah? Multiple different ways you can talk about that. This one we haven't talked about, initial point. Kind of have. What does an initial point mean? Initial is the starting point. Yep, I'm going to say where something starts. Okay, so that's our initial point. I'm going to jump down to terminal point. What does terminal point mean? If the initial point is where something starts, terminal point is where something ends. Yep, and in this case, we're talking about vectors. Okay, a vector is just a line connecting 2 points. What about magnitude? Magnitude is how far / how much. The vector. Okay. Those are the 3 specific things we're going to focus on today for the most part. All right, so what we are going to talk about is this right here is a vector. Okay, this arrow right here is a vector. We want to find the component form of the vector. Okay, what that means is we want to find basically the distance from point A to point C. Which one is my initial point of that vector? A, why? So it's at 10, 10. Why? How do I know that's the initial? It's where it starts, right? Well, let's start with this, terminal. What's our terminal point?
C.
How do I know?
Because it's where the arrow's pointing.
Right, that's where the arrow's pointing. So our arrow is going from here to here. So it starts here, and it ends here. So we are going to find the component form of the vector. Okay, what that means is we are going to find the distance of this vector. Okay, how you find that, this is a formula you can write down. You are going to take your terminal minus the initial. Terminal minus the initial. And that is going to give you something that looks like this. That's going to give you your vector form. So for this one, you can kind of think of it as this is going to be my x and this is going to be my y value. So for this one, terminal minus initial. So here's my terminal and initial. What is the x value of my terminal? 100 minus the x value of my initial. 10. So 100 minus 10. And then what's the y value of my terminal? 410 minus the initial value. 10. Now we just evaluate this. What's 100 minus 10? 90, and then 410 minus 10, 400. So this here, that's called my component form. That's the vector of those 2 points. This is the vector, okay? And the last thing we're going to talk about is we're going to talk about magnitude. So in order to find magnitude, we have to have the vector, okay? So this is another formula you're going to write down. Magnitude is going to be found by taking the square root of x squared plus y squared. Okay. This formula looks very similar to the distance formula. However, I've simplified it down since we already have the vector. We don't have to do all the stuff before. So if I plug values into there, what is my x value of my vector? What's the x value of this vector? 90. So we have 90 squared plus What's the y value of my vector? 400 squared. Now we just evaluate from there. What is 90 squared? 8,100. Thank you. Plus 400 squared, 160,000. What now do I do with those two terms? Add them together, yep. Plus 8,100. So we get this. And then obviously the last step is to what? What do I do with that number? Take the square root. Yep, so take the square root of that number. And you should get 410. That is a coincidence that it's a number from before. That's a coincidence, okay? That's not always going to be that way. Okay. So we found the component form from taking terminal minus initial, and then we use that to help us find the magnitude of the line, okay, or how far the distance of that vector, okay? All right, so on your example 1, how do I know which one's the initial, which one's the terminal? It tells you, right? So that's given to you. Those will usually always be given to you, okay? So how do I find the component form that it's talking about? How do I find the component form of the vector? Yep. Terminal minus initial. Yep, so what is the x value of my terminal? 5 minus 8. And then 6 minus 2. So what do we get for the overall component form? 5 minus 8. Negative 3, 6 minus 2. 4. So that is our component form of the vector. Okay. Now we need to find the magnitude. Okay, so again, that magnitude, what was the equation there? Square root of x squared plus y squared. So we're going to plug these values in. Again, you can treat this as x and y. So plugging those values in, we have negative 3 squared plus 4 squared. What is negative 3 squared? It's positive 9. Yep. 4 squared? 16. And then what do I do from here? Add them together, I get 25. Now I can simplify. What's the square root of 25? 5. So our magnitude is 5, or the length of that vector is 5. To clarify some things, you see this on your paper, yes? Something like that. This right here, that's telling me that's a vector. Okay. So what we're doing is we are doing vector addition. We're adding two vectors together. So it wants to take vector mn plus vector no. Okay. So what do you think I'm going to do with those? Add them together. So I take 9 plus 2, and then I take 12 plus, exactly. Yep. So 9 plus 2, 11, 12 plus 7, 19. That is my new combined vector of those two. And then part B, do you agree it's very similar? Okay, we're just adding two vectors together. So what do I add with negative 3? Negative 3 plus 5. And then 4 plus a negative 8. Simplify, what's negative 3 plus 5? Positive 2. And then 4 plus a negative 8. Negative 4. So we just added the two vectors together to make one component form vector. Are adding and subtracting pretty similar? Yes. Okay, you solve them the same exact way. We just have a different operation. So we are subtracting. So on that first one, A, I take 6 minus 3. Yep. 6 minus 3. And then I take negative 3 minus 2. Okay, so keep going. What's 6 minus 3? 3, negative 3 minus 2. Negative 5. That's it. Okay. Now on the second one, we have 1 minus negative 2. What happens there? Yep. And then negative 3 minus 7. Good. Evaluate. What's 1 plus 2? 3. Negative 3 minus 7. Careful, Nate. It's going to turn out to a negative 10. Yep, be careful with those negatives there. Okay, when we multiplied matrices by a scalar, what did we do? When we multiplied matrices to a scalar, what were we doing? We distributed each term, right? So this one, if I rewrite this, I have 4 times negative 5, negative 7, yeah? I just put vector t in for there. What do you think we're going to do? Oh, that's supposed to be negative 4. Yeah, exactly. We're going to distribute that negative 4 to both terms to give us a new vector. Okay, so this is going to give me negative 4 times negative 5? 20. Negative 4 times negative 7? 28. Okay. Is B any different? No, except we're just multiplying it by 2. Okay, so 2 times negative 5? Negative 10. 2 times negative 7? Negative 14. One thing I want to talk about that I should have probably talked about at the beginning. If I have a vector, someone give me a random vector. Random. Give me a number. I heard 25 and negative 12. Here's my vector. I can write this in matrix form. Okay, so right now, maybe write this example down somewhere. This is in component form. That's in our component form vector. Okay, I can transform this to a matrix form. Okay, what happens? X goes on top, Y goes on the bottom. That is the matrix form. Okay, and then vice versa. If I wanted to go backwards, I can put that in vector form.